an acid is a proton donor. So an H will be transferred from the acid to something else. So it's going to give its proton, and a base is going to be a proton acceptor. So when we say proton, remember, it is not really a proton. The hydrogen has just lost its electron, so it becomes a hydrogen ion, and it immediately goes and clings to a water molecule, and it forms an H3O+. What do we call this ion? A hydronium ion. You don't have to write everything down that I say. I think rather focus and make sure you understand. Everything I'm saying is in your books. Okay, so just so that if there's anything that you really don't understand, you ask. Okay, then for both of them, for acid and a base, we can talk about strong and weak, dilute and concentrated. So 90% you can expect this in your test. Okay, I don't know which one, but you can expect this. So strong, whether it's an acid or a base, doesn't matter. So let's say it's an acid, then it will be H. Remember, an acid always starts with an H. When does it end in an H? Please remember for the organic acids, CH3, COOH. It will donate that hydrogen at the end. For a normal acid that's not organic, it will be something like HClO. You need to know the strong ones. What are the strong ones? HCl, H2SO4, HNO3, nice. So those three are the strong ones, and everything else can be considered weak compared to them. So with so all acids, will they ionize or dissociate? Ionize. When you see ionize, what must you write? Plus H2O. So you have to write plus H2O, and then if it's strong, you're going to put a single arrow, and you're going to show that hydrogen has gone there. You don't have to put the arrow if you just write the equation, but that will form the Cl minus is now on its own. Show that you know that they are swimming around AQ plus H3O plus. Okay, so that's those are the acids. They will always ionize. So you don't have to worry. Whether they're weak or strong, they will always ionize. But if they are strong, well, why do we put a single arrow? They ionize almost completely. So that means if you have a particle diagram and I put HA in here, and that acid is my strong acid, as soon as it hits the water, all of it is going to change into A minuses swimming around and H3O pluses swimming around. You're going to have nothing that is still HA. That's not going to be there for a strong one. But if it is weak, you're going to have some of those that are split up, but in here you're going to have a lot of them that are still HA. So what am I going to do with the arrow then? So then so for HA, which is then weak, you're going to still show that it ionizes, still plus H2O, but now you are going to put a double arrow. Okay, we are going to be strict when we mark this. Double arrow, still going to form H3O plus, still going to form whatever minus. You happy with this? Please stop me if you're getting confused. Some of you are just staring at the board. Say if there's anything that confuses you. All right. So, but this is also the difference between a strong and weak base. But what do bases do? What do strong bases do? They dissociate because all of them are ionic. Okay. So because they are ionic, the strong bases, where are they? Group 1 hydroxides. So you kind of know these things, man. So it's a group 1 hydroxide, so something like lithium hydroxide, potassium hydroxide, sodium hydroxide. That's a base. So when you see the OH, you know it's a base. And for the bases, they don't ionize. So you must not write plus H2O. Whenever it's a hydroxide, you're just going to show that they split up. If you want to, you can write the water on top of the arrow, but you don't even have to do that. Okay, so when this hits water, it's going to split up into an Li plus ion and an OH minus ion. And the splitting of an ionic substance into its ions is called dissociation. Again, flashcards. Yes.
So when it's acidic, would it be ionization? But when it's a base, it's
Dissociation. Yes. But be careful. There is an exception. And that is why the definition, so for a strong base, it says it's a base that that dissociates completely in water. But for your weak one, what does the definition say? Define a weak base.
ion base that dissociates partially.
It could dissociate partially, but it also ionizes. So in your definition, you'll actually see that it doesn't even say dissociate, because we don't really work with the ones that splits up. So in your definition, you'll see it says that it's a base that ionizes completely. And the reason for that is the bases that you are going to use that are weak is going to be something like NH3. NH3. Is NH3 ionic or covalent? Covalent. So it doesn't have ions that can split up. So if it doesn't have ions that can split up, what will it do? Ionize or dissociate? Ionize. If you know that it's ionizing, what must you immediately write? Plus water, because the definition for ionization is it's the reaction of a molecular substance with water. So you have to say plus water because it's a reaction. It's not just splitting up. And now you must just be careful, because now this is a base. What does a base do? Dissociates, but not this one. This one doesn't dissociate. This base ionizes because it's molecular. But what is the definition of a base? It will accept a hydrogen or a proton. So that means the hydrogen is going that way now. So that means we're going to form NH4 plus and an OH minus. So now I'm hoping you can see here. Whenever it's an acid in water, it will always form an H3O plus. Whether it's strong or weak, it doesn't matter. It's going to give us the H3O plus. And that is why the pH, this is definitely in your test, the pH depends on the H3O plus concentration. So if I have a lot of H3O pluses, remember if we put it in square brackets, it means concentration. If the H3O plus concentration is high, what will my pH be? Very low, because it's a strong acid. Okay, well, not necessarily strong, but it has a high concentration of H3O plus.
But wouldn't a strong acid have more H3O pluses anyways?
Yes, if it's the same concentration as a weak one. Yeah. So those questions we'll go through, because it is important comparing things. So here, now you can see here for the bases. The bases, all of them, doesn't matter if they ionize or dissociate. This one was dissociation, this one was ionizing, but they both formed an OH minus ion. Okay, so that means they're a base. So now if you're looking at this, if I have these, if I have a lot of OH minuses, if the concentration of OH minus is high, it automatically, because these two are inversely proportional to each other, if the OH minus ion concentration is high, it will immediately tell you that the H3O plus concentration must be lower. And if the H3O plus concentration is lower, what is the pH going to be? Higher, showing that it's a base. Okay, so this you need to know how the pH links with the concentration of the H3O pluses. Happy so far? Okay. If it's, so you know the difference now between strong, weak, strong and weak. So again here, what did I do wrong here? It's a weak base. So it ionizes partially. So you need to have a double arrow. When it's a double arrow, what does that mean when you see a double arrow? It can go both ways. It's a reversible reaction. Tell me the definition of a reversible reaction. Where the products can be turned back into reactants. William?
Wait, now for the second acid, they're always supposed to put the AQ.
Yes, always put the AQs.
And that's a strong acid.
This one? If you have a double arrow, weak. Okay, double arrow is always weak. Now, how can I make this dilute? You just put more water in. So this is concentrated, meaning there's a lot of acid particles for the amount of water, not caring whether they have dissociated or ionized or not. There's just a little bit of water. But if I now want to make it more dilute, all I'm doing is I'm adding in more water. So then so that water becomes extra, so the volume becomes bigger, but the same amount of particles. So dilute and concentrated all depends on the amount of water there is. Lots of water for dilute, little bit of water for concentrated. It has nothing to do with ionization or dissociation. Just the water. It's like diluting Oros, remember? Okay, that's all it is. Okay, so then after this you did the recipes. So yes, definitely there you would I would say I haven't checked the new version of your test, but I think there might be about 3 of these, which is worth a lot of marks because it's not 2 marks each. So if I say to you that your recipes, you do need to know your recipes. An acid and a base forms a salt plus water. An acid and a hydroxide, salt plus water. An acid and a metal, salt plus hydrogen. I cannot teach you that. You need to know your recipes. So if I give you, let's just use magnesium. So we will probably give you a word equation. Magnesium hydroxide reacts with, what can we use? Iron carbonate. Oh, that's very insoluble. If you do your, you know your solubility rule, so you should know that it's insoluble. It reacts with zinc, also insoluble, I think. Reacts with sodium carbonate. And then we will ask you to write a balanced equation for that. Okay, so all the recipes, we can give it to you as a word equation, and you must write it as a balanced chemical equation. So again, back to chapter 1. Magnesium hydroxide, what is the formula? Mg OH in brackets 2. Guys, this is seen as a level 2, as a form 2 skill now. You've done it last year. Plus sodium carbonate. Na2CO3. Then I'm going to put my arrow. Now you need to know what the products are. It's a metal hydroxide. Oh, I didn't even give you an acid, guys, sorry. It's just, I'm not even giving you an acid reaction. Let's just use, what acid do you want to use? Okay, so we're not going to say HCl, we're going to say hydrochloric acid. So you need to know then that it's HCl. Now using your recipe, it's an acid and a metal carbonate. What is it always going to form? Always going to form CO2 and always going to form H2O. Okay, so you need to know that. But then the other thing is a salt. What is the definition of a salt? The hydrogen of the acid is replaced by the cation. Can you see that it's again your flashcards? So you're kicking out the hydrogen and you replace it by the sodium. So it's going to be an NaCl. Once you've done that, you do the balancing. So don't put any small numbers that doesn't belong. Now you go and do the balancing. There's 2 H's there. I need 2 H's there, but now my Cl's are 2. I need a 2 there, and I think it's balanced. So this can be 4 or 5 marks just to write this recipe down, because to know that it's HCl, we give you a mark. To know how to write that formula, we give you a mark. To know that it's CO2 and H2O, we give you a mark. To know the salt, we give you a mark. And for balancing, we give you a mark. So it could literally be 5 marks. That's a lot of There's a big percentage of your marks, guys. So know the recipes. Okay, so I'm not going to go through all of them. You've got a lot of examples in your book. Make sure that you know the acid reactions. Okay. Then you need to know what polyprotic, amphiprotic, and all of those things are. So if I have HCl, how many hydrogens can it donate? Only one, because there's only one, so it's going to be called monoprotic. Give me an example of a diprotic acid. H2SO4. Triprotic. Yeah, H3PO4. Okay, so there we go. So, 4. So this is a triprotic acid. Which of these is weak? Will be weak. Yeah, this one. You know, guys, you just told me that these two are strong. And this one is weak. Okay, now, in the test, we're not always going to ask it like that. We're going to say, which one of these three, if the concentration is the same, so let's say they all have a concentration of 2 mole per cubic decimeter, which one of these will conduct electricity the best? I want one.
H2SO4.
I've got a HCl, I've got an H2SO4.
It's H2SO4, donate 2.
Guys, remember, what does conductivity depend on?
H.
The number of, okay, tell me again, what is an electrolyte?
A substance that has more ions to conduct.
Yeah, you had the card just now. So it's a substance that can conduct electricity because of free moving ions when molten or dissolved. So the more free moving ions I have, the better they will conduct electricity. But this one, it's H3PO4, but it's weak. So is it going to ionize completely? No. HCl is going to ionize completely, but it gives me 1, 2 ions every time. This is also going to ionize completely, but it gives me 2, 3 ions each time. So which of them are going to give me the most ions that are free to move to conduct electricity? H2SO4. Remember, if they ask why, you have to say more ions that are free to move. Yeah, and so if they say explain why, then you can say that it's strong, therefore ionizes completely, forming many ions that are free to conduct electricity. Free to move, free to move. You have to say move. Okay, so this type of question, definitely comparing things with conductivity, comparing things with strength, comparing things with pH. Okay, so that will be there. I think that's going to be like about, probably 6 marks.
What do we say? Do we say more ions that are free to move?
To conduct electricity, because it's a strong acid and ionizes completely.
So
Yes.
If they ask which acid is stronger between HCl and S2O4, how do you do that?
You can't. Because what is strength determined by? Ionizing completely, not the amount of ions. And this one will ionize completely, and this one will ionize completely. That's why we see them both as strong. So we can't ask you which of these two is the strongest one, because they both ionize completely. Only later on when you do Ka values, maybe we can do that, but not now. Okay, both of them ionize completely. This one will ionize partially. Double L.
So it's more ions that are free to move, more ions that will then conduct electricity and will ionize them.
Yeah, it's kind of just the wrong way around. You must start with saying they ionize completely, therefore there are more ions that can move. Okay, the ionize completely is the reason for the more ions. Okay, so this type of thing, definitely you need to be able to compare them with pH, with conductivity, and with strength.
But
Yeah.
why would it conduct why would ionize completely?
Because they are the strong ones. You need to know the 3 strong ones. So for now, you just need to know that those 3 strong ones will ionize completely. Sulfuric acid, hydrochloric acid, nitric acid. And the definition of a strong acid is that it ionizes completely when it hits water.
So now, if they ask why strong acid is why strong acid is stronger than weak acid is because one ionizes completely, another. Okay.
So that is a typical example of a question where you're using the definitions, but it's not a defined question. And you're going to get many of those, guys. Chemistry is full of these things. Explain this, explain this. I'll open a test just now on this that you can see what I mean. Okay, so then you're always going to use your definitions, yes. Then the last thing really in this chapter was precipitate reactions. Oh, wait. Amphiprotic. What does amphiprotic mean? Acid and a base. So the middle things, remember, if I look at H2SO4, anything that is polyprotic, more than one hydrogen. If I look at H2SO4, is it going to ionize or dissociate? William, ionize or dissociate? It's an H. As soon as you see the H, it's ionized. Don't even have to worry about it. Because then immediately, if you know it's ionized, what are you going to write?
H2O.
Plus H2O. So please be careful. If it's H something, if it's an acid, it's always going to ionize, and you're always going to write plus H2O. Now what's going to happen is we form an HSO4 here. So because it only gives one hydrogen, if we do it in 2 steps. Gives one hydrogen and it forms an H3O+. But then this thing here, can you see that it has a hydrogen to still give? So it can still give that hydrogen. So in step 2, that thing that we formed, that middle substance, can give another hydrogen. Remember, there are millions of waters around. Can give another hydrogen to that, and it's going to still be... why did I make a single arrow? It's H2SO4 is strong. You need to know that. And this, then all the H's are gone after that. I'm just left with SO4 2 minus and another H3O plus. But now you can see here, this substance here gave a hydrogen. But if I go back, it could give a hydrogen. So where you see a substance that can give or take a hydrogen, we're going to call it amphiprotic. Know that definition as well. All right, and then the last thing was the solubility, the precipitate reactions. So for precipitate reactions, we're going to give you random stuff. We're going to say, okay, I have BaNO3 reacting with K2SO4. Okay? And you need to go and write a balanced equation for this again. Okay? And for this one, we can also ask you to write an ionic equation. So please make sure that you can do it for the precipitate reactions. So here, we need to see, on your solubility rules, we give them to you. So you don't have to worry about them. You will always get them. So the solubility rules here somewhere. You can see here what will dissolve or not. Okay, so if I look here, I've got a Ba, an NO3. Okay, so let's write the ionic equation. So I'm going to have a Ba. Oh, is that formula even right? What must it be?
It's BA bracket NO3.
Please make sure that you don't do that. So I've got Ba2 plus, and I've got NO3 minus, but I've got 2 of them. I also have 2K pluses, and I have SO4 2 minus, because they would probably tell you that these are AQs. Soon as they're AQs and you see they're ionic, they can split up. What do we call the splitting of an ionic substance into ions? Dissociation. Okay, you put an extra as in there. You say disassociation.
Dissociate.
But lots of people do that. It's just dissociation. Yeah, lots of people do that. Okay, now we need to see, remember what I just said earlier. There's some stuff that will always grab something and drag it down with itself. Okay, so from the solubility table, you need to go and look. Is there something here that would like to drag something else down? So if you look at your solubility table there, we have a BA. So you just find what they tell you about BA. Is there anything about BA here? Yes, there. Okay. BA would drag down what? An SO4. Okay. We'll drag down an SO4. What else would it drag down?
NH4, OH.
An OH. A BA would drag down an OH. So is there something there in our reaction for the BA to drag down? The SO4. So now what you're going to do is you're going to say, fine, my BA is going to drag down the SO4. So you just join them and you make them a solid. So that is going to be BA SO4, and you put the solid. So they're not swimming anymore, they're not AQ anymore, they're on the bottom of the beaker. Yes, William?
Now, do we need to remember the solubility?
No, we give it to you. You just need to go and check.
And type it.
Yes. Didn't you see the test just now? Yeah, no, we do give it to you. And then you look at the other ions. Is NO3 going to drag down K or KNO3? They don't want to drag anything down. Nitrates are the things that are always soluble. Group 1, always soluble. So they always want to swim forever. And that means that I'm still going to have my NO3 swimming around, and I'm still going to have my K pluses swimming around, and you can do the balancing. But, so, what do we call these ions? These ones that didn't change. Good. They are called spectator ions because they didn't actually form a part of the reaction. So now here we can also ask you for the net ionic equation. So if I ask you for the net ionic equation, what am I going to leave out? The spectator ion. So just the things that change, you're going to put Ba2 plus SO4 2 minus forms Ba SO4, and your textbooks, your notes calls this the driving force of this reaction. Because if it wasn't for that solid that was forming, these ions would just swim around forever. They would never bond or react with each other. Happy? Okay, this is important. Lots of marks. Lots of marks. That's acids and bases. Anything else about acids and bases?
Could you please explain the third rule?
The?
The third rule of solubility.
Explain. What did I do with it? Oh, the halogens. So they will always be soluble. So they would always swim, except if they are in contact with a silver or a lead ion. That silver will drag down these ions. And the lead would drag down these ions. So that's all it means. It says they are soluble. Soluble means they're swimming. So they will be soluble except if silver or lead drags them down. Okay. That's acids and bases. So, yeah, I'm going to freeze. Just want to see that we've covered everything. Is it frozen? Yeah.
What's your report?